Okay, in this presentation we're going to look at a continuous random variable question. So the continuous random variable x has probability density function given by this expression here. F of x is equal to kx squared times 1 minus x to be squared. And the range of values there is 0 and 1. So the upper and lower limits when we do definite integrals will be 0 and 1, or upper and lower being 1 and 0. Okay? So it is 0 elsewhere. So we can essentially just focus on the range of values between 0 and 1. So the first part of the question asks us, find the value of k and sketch the graph of f of x. Now I'm going to sort of focus on finding the value of k because sketching it should be a fairly trivial exercise, just evaluating the functions and so on. So the probability density function for between 0 and 1, where x is between 0 and 1, is given as f of x equals kx squared times 1 minus x to be squared. What I'm going to do is partially simplify that. I could go a little bit further, but I'm just happy enough with what this is, what we have here. That is equal to kx squared times 1 minus 2x plus x squared. So I could actually express it out a little bit more, but it was just a sort of no real reason why I didn't do it. Now, the trick to this question is that the total area of the probability density function is 1 between the upper and lower limits. So when we integrate the curve, the PDF, essentially what should happen here is between the upper and lower limit, the total area should be 1. I'll come back to that shortly, but this is the trick to this question. So let's go down to the next page. So here we are. What we're going to do here is integrate it. Now I've actually sort of took one big step there very quickly. The area is the integral of kx squared times 1 minus 2x plus x squared. Really what I should have done there is I've taken out k, okay, and put it here on the side just to make life a little bit easy for us, okay. But what I've done here is x squared, that when we integrate that, we have 1/3 over 1 over 3 times x cubed. Now, x squared times 2x is 2x cubed. When we integrate that, we get, well, x cubed is x, when we integrate x cubed, we get x to the power of 4 over 4. Because it's 2x cubed, we have, instead of 1 over 4, we have a half, okay? And finally, x squared times x squared is x to the power of 4. When we integrate that, we get 1/5 of x to the power of 5. Now this is a definite integral between 1 and 0, or 0 and 1 if you prefer. What I'm going to do here is just evaluate, essentially what we're going to do is evaluate each expression there at 1 and 0 and get the difference. Now I've actually done it expression by expression here. So 1/3 of x squared, when that is equal to x is equal to 1, is 1/3. When it's equal to 0, 0. Okay. Likewise, a half of x to the power of 4, when we evaluate it out 1, we just get a half. And when we evaluate it 0, we get 0. And so on. Likewise, there for 1/5 of x to the power of 5, we get 1/5 minus 0. I just done an expression by expression there. You can go other ways about it. There's no right way or wrong way. So I just took 3 parts there and treated them as 3 separate definite integrals. Okay, you could do it as one big expression and evaluate it 1 and then subtract it when you evaluate from 0. I just find it easier to work with this way. So essentially what we have here is k times 1/3 minus 1/2 plus 1/5. Let's express that as as fractions over 30. 10 over 30 minus 15 over 30 plus 6 over 30. That means we have the area is k times 1 over 30. The area is equal to 1, so necessarily k is equal to 30. Okay, now this is a sketch of the curve there. I recognize that it's probably a little bit hard to read, but there we are. It looks quite symmetric. Okay, there's the curve there, and we between 0 and 1. We just notice that it peaks here about halfway and that it's symmetric. Okay, so that's halfway between 0 and 1. That is 0.5. Now, just actually what I was sort of getting at here is the total area under this, when you evaluate it mathematically, all of this bit I'm trying to fill in and not doing a very good job, that the total area should equal to 1 there. That's the idea of a definite integral between 0 and 1. Okay, so let's move on to the next part there. So just as a remark, f of x equals 0 at x equals 0 and x equal to 1. It's symmetric about x equal to the 1/2, as I just pointed out. So we can make a guess there that the expected value of x equals 1/2 by symmetry. I'm going to come to that in the next question, but if you're sort of looking at that graph and you have build up a bit of a judgment for it, and you know it's symmetric, you just sort of figure out where is the highest point. Okay. Now, typically, the highest point corresponds to the mode, not the mean, in a skewed distribution. So, but because a symmetric distribution, the mode is also the mean. There's a lot of stuff going on there. It's outside what this question is about, but just as a remark, it's symmetric. That's why the highest point should be the mean. But usually, the highest point is the mode, and if the distribution is symmetric, then the mode is the mean. So the second part is find the expected value of x and the variance of x. Okay, now this is a very important little formula here. The expected value of x is the integral of x times f of x between our limits 0 and 1. Okay, and again, we're told them in the question. So what we're going to do here is there you have it there. Okay, now actually that's a bit of a meaningless expression. I'll just actually get down to the main part here. So we're going to take out 30 out of it. Okay, just earlier on. So this is, when we take 30 out of it, f of x is that expression there. Oh, I'm missing a bracket, please forgive me. X squared times 1 minus 2x plus x squared. When we multiply that whole thing, we will have it as x cubed times 1 minus 2x plus x squared. So that's a standard definite integral. X cubed, the standard definite integral of x cubed minus 2x squared, 2x to the power 4 plus x to the power 5 dx. And it's a straightforward definite integral here again. So we have x cubed, the integral of that is x to the power of 4 over 4, minus 2x squared is, well, you can, ignoring the minus sign there, the minus sign, watch the signs of course, but when we integrate that we have, oops, don't do that, we have 2 times x to the power 5 over 5, and finally when we have x to the power 5, the integral of that is x to the power 6 over 6. Now again, definite integral between 0 and 1, and what I'm going to do is each expression one by one. So we have 1/4 minus 0, minus 2/5 minus 0, and plus 1/6 minus 0. Okay, so essentially we're evaluating each of those expressions at 1 and 0 and getting the difference there. So when we work it out, 1/4 we re-express that as 15 over 60, 2/5 is 24 minus 24 over 60, or well, again, we're using that sign there, and 1/6 is 10 over 60, so it's plus 10 over 60. So 15 minus 24 plus 10 all over 60, that is 1 over 60, and remember our 30 there? Okay, so that gives us 30 over 60, which is 1/2 or 0.5, which is what we would have guessed looking at the graph. So the next part is we have to do now is find the variance of x. Now, but there's a step we have to do in the meantime. So we have to calculate the expected value of x to be squared, or x squared, okay? That part there, that expression there, x squared. And it's very similar to the expectation, the expected value of x, except what we're dealing with is x squared as opposed to x. That's the only difference. So it's a standard definite integral again. So when we work it out, we have x squared times 1 minus 2x plus x squared, or x squared. So x to the power 4 times 1 minus 2x plus x squared. Working it out, x to the power 4 minus 2x to the power 5 plus x to the power of 6. And again, sorry, just as a remark, I took the 30 out of it and put it before the integral symbol there. Just that's a habit of mine. I just like to keep things nice and tidy. So x to the power of 4, when we integrate that, is x to the power of 5 over 5 minus 2 times x to the power of 5 when we integrate that, 2x to the power of 6 over 6, which will reduce to 1/3, and again x to the power of 7 over 7, that comes from x to the power of 6. So 1/5 minus 0 is when we integrate each expression, evaluate each expression at 1 and 0, and so we have 1/5 minus 0 minus 1/3 minus 0 plus 1/7 minus 0. Just as a remark, I always do that because sometimes when you evaluate at 0, you get an expression that is non-zero, and you might get 1/5 minus something that's not 0. So just double check that you don't get any nasty surprises by doing that. Just always double check that when you integrate at 0, that it should evaluate. So again, same as before, 1/5 is 21 over 105, 1/3 is 35 over 105, and 1/7 is 115 over 105. That's just the 105 is simply the multiple of all three numbers there, lowest common multiple. So 21 minus 35 plus 15 all over 105, that is 1 over 105. And again, we have our 30 here. 30 over 105, that works out to be 2/7. Okay, 2 over 7. So the variance is as follows. This is a very important expression. We have two expressions there. The variance is the expected value of x squared minus the expected value of x to be squared. Okay, and again, always remember that those are two different expressions there. That and that are not equal to each other. So we're just using the numbers we found already. 2 over 7 minus 1 over 2 to be squared, which is 1 over 4, which is 7 over 28. And 2 over 7 is 8 over 28. So when we get the difference there, we work it out. 2 over 7 minus 1/4, that works out to be 1 over 28. Okay, so that is our variance. So the next part is as follows. Show that x, the probability of x being less than or equal to 1/3 equals 17 over 81. Now, this is another integral, and rather than integrating from 0 to 1, what we're going to do is integrate from 0 to 1/3. Okay, so essentially I've got this far here, and this is actually using the same sort of results as I got in part 1. But what I'm doing there is, first off, I know that k is equal to 30, and rather than using the limits of 0 and 1, what I'm doing there is using the limits of 0 and 1/3. Just actually as a remark, 1/3, less than 1/3 is also the same as between 0 and 1/3. So that's why we can integrate from 0 to 1/3, because it can't go below 0. So both of those expressions are directly equivalent to each other. So now this is a little bit tricky here. This is where you have to be a little bit careful about what you're doing. So I'm going to put the whole thing up there. And 30, yeah, we can leave the 30 out of it. So x cubed over 3, when we evaluate that at 1/3 and 0, all our zeros come out of the expression. So essentially what we have to do here is be a little bit careful about what we're doing. So there's a number of ways of doing this. Essentially the way I'm going to do it is there, 1/3 cubed over 3 is the same as 1 over 3 to the power of 4. 1 over 3 to the power of 4 is times 2, divided by 2. And I'm going to call that 15 over 30 times 1 over 3 to the power of 4. Okay. And finally, this is sort of informed by what's coming up later on. 1 over 1/3 to the power of 5 times divided by 5. Well, we're going to call 1/5, we're going to rename it as, or re-express it as 6 over 30, and we're going to split up 1/3 to the power of 5 as 1/3 by 1 over 3 to the power of 4. So essentially what we have there is three expressions that include 1 over 3 to the power of 4. So we have 30 over 30, which is this one, minus 15 over 30 plus 2 over 30. So it does work out to be 17 over 30. This part here, 17 over 30. 30 times 1 over 3 to the power of 4 is 30 divided by 81 times 17 over 30. There we have it there. The answer is 17 over 81. Okay, now you can do it with a bit of calculator work, but it's essentially just being smart about factorizing things there. Now, when I went from 15 over 30 and 6 over 30, that was a little bit of an informed decision. So you might come to that yourself if in an exam situation after one or two attempts. So 17 over 30 is what we're looking for there. Show that it is 17 over 81. Sorry, 17 over 81. Okay, a random sample. So we got two short questions to finish up with. A random sample of 5 is taken from this distribution. Find, correct as 4 decimal places, the probability that all 5 observations exceed 1/3. Well, essentially, the probability that one observation exceeds 1/3 is the complement of what we just got, which is 64 over 81. And independent events, essentially, it's 64 divided by 81 to the power of 5, which is 0.3079. And one more question, party. State correct 4 decimal places the variance of the mean of a random sample of size 5. So we have a sample of 5 items. What is the mean, the variance of the means of samples of 5? Essentially, this is a sampling distribution, and what we do there is we get the variance of the underlying variable and divide it by the sample size to get the sampling distribution of the mean. So what we have here is the variance divided by the sample size, and that is the sampling distribution, or the standard error. So essentially it is the variance divided by n, which is 1 over 28 divided by 5, which is 140, which is 0.00714. Okay, that was a very long question, so I'm going to think we'll wrap it up there.